Yabba dabba doo! Welcome to video lesson 4-4, boys and girls. Video lesson 4-4, part 1. Okay, these are our steps to factoring, and if you need extra help in factoring, I have another video, a video on factoring only you can go back and look at. That's on Google Classroom. Okay, but steps to factoring are right here listed out. These are our Algebra 1 steps for factoring. First step is list the terms in descending order. Factor out any common monomial factor. This is the important part. It makes our math much easier. Look to factor out a greatest common factor from each term in the polynomial. Look for special products. Some of the special products that we're going to be dealing with is differences of squares, differences of cubes, and sum of cubes. Okay? Then you do either trinomial factoring or factoring by grouping. Once you've factored, you're going to check the primeness of each factor. We will go over these in a momentito. Alrighty, right now, please write these perfect squares down into your notes. These are numbers I would expect you to just know. You should know 1 squared is 1, 2 squared is 4, etc. 10 squared is 100. I am hoping we all know our perfect squares up to 10. 10 squared is 100. Also, you just want to kind of just know without a calculator, without a calc, you should know your perfect squares up to 20. A minimum up to 20. So make sure you familiarize yourself with these perfect squares. Take a second and write down these perfect squares up to 20 right now, and I'll come back. Write these ones down as well. These are our perfect cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, etc., etc., all the way up to 10 cubed is 1,000. Okay, factoring is the inverse or the undoing of multiplying. It's like dividing. Factoring is dividing. When you start with the factors. Factors are things that we multiply to get a product. So factor times factor is equal to product. If you take the product and you break it up, you're dividing, and then you get a quotient. So 3 times 4 is 12. 3 and 4 are factors. 12 is called the product. Okay, type 1. Type 1 of factoring is monomial factoring. In other words, we're going to factor out a greatest common factor. And again, this is very important first step to factoring. So let's go back to Algebra Uno just for a second here. And let's take 3x plus 6 and look for a greatest common factor in both 3x and in 6. Is there a number that is, or a variable, is there something that is common to both 3x and 6? Very good. You got it. 3x and 6 can both be divided by 3. When I do that, 3x divided by 3 is x, and 6 divided by 3 is 2. So I keep my original factor. I can factor 3x plus 6 into 3 times x plus 2. If I were to distribute this 3 back through x plus 2, 3 times x is 3x, and 3 times 2 is 6. Notice when I distribute my 3, I'm back to my original expression. Okay? This right here, this is called the multiplied form or the product form of my binomial. This is my factored form of my binomial, 3 times x plus 2. Okay, looking at this guy right here, is there a common factor to both x squared and 9x? Yes, there is. There is a common factor. What can go both into x squared and 9x? The answer is x. So I'm going to divide both of my terms by x, keep my term, my factor, x, and what's left when I divide x squared by x? I get x minus 9x divided by x is 9. There is my answer. This is my factored form of this expression. If I were to check this and multiply, x times x is x squared, and x times negative 9 is 9x. That's just my check, but my answer, my factored form, is x times x minus 9. Okay, you guys try this one. There are now 3 terms. There are 3 terms. Is there a common factor? Is there a common factor to all 3 of those terms? Go ahead and find that common factor, and I shall be right back. Okay, you should have found a common factor of 5x. 5x goes into all 3 of these terms, so I divide each term by 5x. So my factor form is going to have my factor, my monomial greatest common factor of 5x, and what's left is 2y minus 1, so 2y minus 1 plus 5x. If I were to distribute this 5x through to each of these terms, I would end up back here, but this right here is my factored form. Okay, let's talk about type 2 of factoring, looking for special products. The first one is differences of squares. The model is a squared minus b squared is equal to, now be careful here, it's a minus b times a plus b. We call these, of course, conjugates, which we've talked about. So a squared minus b squared factors to a minus b times a plus b. If we were to FOIL this out, if we were to FOIL that out, you would see that the middle terms cancel. So looking right here, I have x squared minus 9. This can be thought of as, whoop, I need my marker. This is going to be x squared minus 3 squared. So this factors now to x minus 3 times x plus 3. If I were to FOIL this out, you're going to see what happens here. X times x is x squared. X times 3 is positive 3x. Negative 3 times x is negative 3x. And negative 3 times positive 3 is negative 9. You can see now what happens to my middle terms. Plus 3x minus 3x, they go away, they cancel out. So I'm left with x squared minus 9, and you can see that was our original expression right here. So our factored form is going to be right here, x minus 3 times x plus 3. Okay, looking at this guy right here, we have x squared minus 121. I'm hoping you immediately recognize now that x squared minus 121 is x squared. This is from our list we just wrote down, minus 11 squared. You guys go ahead and factor that right now. Go ahead and factor that. Okay, you should have had x minus 11 times x plus 11. That's our final answer right here. Here's our final answer. But if we were to FOIL, x times x is x squared. X times positive 11 is plus 11x. Negative 11 times x is negative 11x. And negative 11 times positive 11 is negatory 121. Notice once again my middle terms are going to cancel, and I'm left with x squared minus 121. This is a difference of squares. This is a difference of squares in product form. This is a difference of squares in factored form. You guys go ahead and try this one right now and go ahead and factor it. Okay, you should have found you get 2x plus 5y squared times 2x minus 5y squared, because I looked at 4x squared and I noticed that's the quantity 2x squared. And I looked at 25y to the fourth and I noticed that that's the quantity 5y squared squared. 5y squared squared. So I have a difference of squares which factors as to 2x plus 5y squared, 2x minus 5y squared. These two factors, when written like this with the plus and minus, these are called conjugates, and we're going to use that term a lot. Okay, our second type of special products are sums and differences of cubes. This is the same idea as differences of squares, but it's just a little more complicated. That's all, just a little more complicated formula. But we have a sum of cubes, a cubed plus b cubed, factors now, not as a plus b quantity cubed. We know by binomial expansion that that's different. But a cubed plus b cubed factors to a plus b times the quantity a squared minus ab plus b squared. A difference of cubes factors a cubed minus b cubed. A difference, subtraction. Difference of cubes factors as a minus b times a squared plus ab plus b squared. So looking right here now, we have x to the third minus 27. This is a difference of cubes because x to the third is x to the third, and 27, of course, is 3 to the third. So to factor this now using the formula up top where I have a to the third minus b to the third. But a is now x and b is now 3. So this is going to equal, I'm going to replace a with x and b with 3. So this is going to be equal x minus 3, that's a minus b, times x squared, or a squared, which is x squared, plus a times b, well, a is x and b is 3, so that's 3x, plus b squared, of course, is 3 squared, which is 9. There's my final answer, x minus 3 times x squared plus 3x plus 9. Just for the fun of it right now, let's FOIL this out. What's x times x squared? That's x to the third. What's x times 3x? That's 3x squared. What's x times 9? That's 9x. So I need my parentheses right there. That's 9x. I'm now going to distribute the negative 3 minus 3x squared. I'm going to write that right here. Minus 9x. Negative 3 times 3x is 9x. And negative 3 times positive 9 is negative 27. We can see now what happens here. Our middle terms are going to cancel. The 3x squareds go. The 9x's go. And I'm left with just x to the third minus 27. And again, this is our product form of a difference of cubes. This is our factored form of our difference of cubes. Okay, this guy right here, we have a sum of cubes. This is x to the third. You recognize x to the third as x to the third. And hopefully you recognize 216 as 6 to the third. So we're going to take x is a, and our b is 6. And we're going to take this and we're going to put it into this formula up here. So I'm going to replace a with x, so this is going to be x plus b is now 6, times x squared, well, a squared, which is x squared, minus ab, a is x and b is 6, so that's 6x, plus b squared, well, b is 6, so 6 squared is 36. Here is our final answer. This is the factored form of a sum of cubes. And this, of course, is our product form right here. Just for the fun of it, if I were to FOIL this out, you guys tell me right now what's going to happen to my middle terms. Very good, they cancel out. But x times x squared is x to the third. The second one, x times negative 6x is negative 6x squared. X times positive 36 is 36x. Down here at the bottom now, we'll do this in blue. 6 times x squared is plus 6x squared. 6 times negative 6x is negative 36x. And 6 times positive 36 is positive 216. We can see what happens once again to our middle terms. They go away, kind of like what the girls used to say to me, but any which way, they go away, and I'm left with x to the third plus 216. Okay, our last one right here, this is 64x to the third minus 125y to the sixth. I'm hoping you're recognizing this as a difference of cubes. This is going to be, in essence, 4x quantity cubed minus 125y to the sixth. If you look closely now, that's 5y squared quantity cubed. You guys go ahead and finish this problem. Go ahead and factor that difference of cubes. Okay, you should have gotten 4x times, 4x minus 5y squared times, okay, the a squared, the 4x quantity squared, is going to be 16x squared. That's 4x times 4x, plus ab, that's going to be 4x times 5y squared. 4x times 5y squared is 20xy squared, plus 5y squared squared. 5y squared squared is 25y to the fourth. That's a 4 right there. And that is your final answer, your difference of cubes written in factored form. That's it, folks. Have a great night. We shall see you soon.